Hey guys, welcome to DevOps In this video tutorial, we are going to learn about Kubernetes. Kubernetes is developed by Google and it is an open source platform that automates container operations. It eliminates many of the manual processes involved in deploying and scaling containerized applications. After going through this tutorial, I promise you that the concept and understanding of the Kubernetes will be absolutely clear to you.
But before that, let me ask you a few things. Are you dreaming of a career with higher pay and more responsibilities? Or are you ready to take your skills to the next level this year? Then start investing in DevOps certification level courses which will help you to emerge skills for a wide range of entry-level roles and as well as higher potential future positions. But with thousands of courses online and in classroom worldwide, finding the right one for your career goals can be difficult. You can consider our courses like Agile Developer, Agile QA, DevOps Certified Professionals, Site Reliability Engineering, DevSecOps, and Masters in DevOps Engineering, where you will have access to well-structured, easy-to-follow course content that has been developed and will be delivered by industry professionals. You can join on our training programs globally through online platforms, and if you are looking for classroom workshops, then we have regular sessions available in Bangalore, Hyderabad, Chennai, Delhi NCR, Mumbai, and in Pune. Simply compare our many courses, find the one that suits your style and schedule best, and start today.
Now we are going to understand the Kubernetes architecture. Very important. Kubernetes architecture. So as part of the Kubernetes architecture, we are going to understand the master, we are going to understand the nodes, we are going to understand the pods, services, deployments, and we'll do the review. So let's understand the Kubernetes is at the big picture. Big picture. Kubernetes is an orchestrator for microservices app also. So first time when I said what is a Kubernetes, then I said Kubernetes is a container orchestrator. Now what I'm saying is Kubernetes is also an orchestrator for microservices app also. Now what is the microservices? So anyone would like to tell me what is microservices?
The application splitted into module level.
Yeah. So see guys, now we are in the world of microservices, not service. Let me just give you the little bit visualization, because if sometime, let's say 4 or 5 people don't understand, then it's become very difficult to other topic to grasp. So for those people, I'm just covering. This is a complete product. Think about it. How many people are working here? 20 people. How much release you are able to do that? Every day one release. Daily. One day, one release you are doing. Now, can we do that, this release, reduce the time and make it convert to immediate release? When I say immediate release, that means typically, if you are following the Agile and all, you do the release once in a 2 weeks. But here I said daily. So mind it. And then we are focusing on the immediate release. So immediate release means, let's say 1 day to, let's say 10 minutes release time. Then you will say, how can it be possible? 10 minutes is too much. In the 10 minutes, you can do the planning, you can do the coding, you can do the testing, you can do the all this sort of work. How can it be done in 10 minutes? Then you have to change the architecture. That is where the architecture is needed to be changed. So let's understand this. So guys, here you have a feature. How many features you have? 20 features. Okay. So what we will do, this 20 feature will slice it down in a small feature. 1, 2, 3, 4, 5, 6, 10, 15, 20. Now what we will do, we will assign this as a one microservice. Earlier it was a service. Now it's become a microservice. Now code, earlier we had 100 MB. Now it's become a 5 MB code. So now how much time it takes to build a 5 MB? Hardly few minutes. 100 MB used to take more time to build it also. Now, how many teams required to manage the 5 MB? 1 or 2. 1 people for this, 2 people for this, 1 people, 2 people, 1 people, 2 people, 1 people, like this. So now you see that what you are doing, you are alone for 1 microservice or maybe maximum 2 people. So what you are doing, you are managing only 1 microservices, the 5 MB of code, not 500 MB of code. And whatever you do, you can do that. So what you have to become, you have to become a developer, you have to become architect also. You have to become a developer also. You have to become a QA people also. You have to become operations also. That is what we call it DevOps, right? Nowadays, DevOps means what? See, if you think DevOps is like operation guys, wrong. You are wrong. That is called SRE. DevOps means a person who can see the high level picture, design the code, planning, design, testing, and deployment to the production. Only one person. That is called DevOps or stack developer. Full stack development. End to end things you do that. So now you see that you do the code changes. It can be done in 2 minutes, planning everything, and probably you can deploy every 10 minutes or whatever. So here what I'm saying, my question was, Kubernetes is an orchestrator for microservice app. So now the question is, here I have a 20 microservices, but in real time, guys, you will have 100 microservices. Now the question is, who will manage these 100 microservices? There should be some person. No, you will say, I am managing my microservices. I will say, I am managing my microservices. Who will manage all these microservices and provide a single platform? Again, I repeat, all the microservices will get a single platform from where they can access each other. Kubernetes can help you. Kubernetes can help you here. Remember, there is a 2 keyword which I am telling you. Microservice, the one which I explained you, and tomorrow I'll talk about 1 keyword, service. You will see that how can you manage your service, your own service, small microservice, each one of you, and still Kubernetes will manage all of the service and make it at one common platform. So that's the reason we call it a Kubernetes an orchestrator for microservice app. With that, guys, let's discuss about this one good story. Look at this here. This is the football ground. You have a team. You have a manager. Right? So here you have a team and here you have a manager. So now what is the goal you think? Objective. What is the objective? For each one of these players, what is the objective?
They need to win the match.
Win the match? Yeah. So many people say just to make a goal. Make a goal. So if you have a goal to make a goal, then all the team players will be near to the goal post because everyone has objective to make a goal. So everyone will try to accomplish their goal. That is how we used to play in our childhood days, right? So that's a goal. Let's make a goal. But do you think like this you can win the match? No, of course no. Guys, that is where the manager comes into the picture. Coach comes in the picture and they're saying, see, I know each one of you. What you are good at, what you are bad at, and what you are supposed to do on the ground. So if you follow me, I will let you play in the ground. If you disobey me, then I will throw you out of the ground. That is what manager says, coach says, or master says. So now when the guidance comes from the manager, master, coach, then all the players start playing in the right direction. Now they communicate as per the design. So each of the player has a certain distinct qualities. Someone is very good at saving, someone is very good at strike, someone is very good at coordination between the front end and back end. So it's like this. So now what each of these players are communicating with football. So they are passing a football from one player to another player. They pass that. They do not take it. Just they pass it. Their job is to pass it. Because they are not supposed to run too much. Because if they run, they get tired. Ball don't get tired. At the same time, ball can run faster than a human. So they should pass it. And those teams who play with a lots of great coordinations, those who win, you know that. So now why this was possible? How come this was possible? This was possible because of manager, coach, master. So guys, like this, in the world of microservices, the one which I discussed earlier, in the world of microservices, you have hundreds of microservices nowadays. More than that, hundreds of microservices, and each microservices, understand that, each microservices need guidance, control to send a request and response to another one. See here, what is there in the request and response in this image? Football, that's a request and response. I will receive request from you and I will send it to you. You will not send it to me, I will not send it to you. This is kind of request and response. Depends on who manage all these things. Manager. Who's supposed to talk to which one. That is where, if you see that in the real time, in the product, you have so many microservices. Now, you have so many microservices running inside the cluster. Now the question is, who will communicate to which one? Who will create this control? Kubernetes. So guys, Kubernetes will control the flow of who should talk to which one. Look at this here, load balancer talking to the only HTTP server, not search, not auth, not KV store. So who should control it? Kubernetes will control this flow, and that is where you see this image is interesting. HTTPS 1 in the node 1 and node 2, but still the behavior is same. These services. So guys, that is what Kubernetes is, an orchestrator also for microservices app. Microservices app. Did you understand this, guys? Everyone? So if you have microservices, too many microservices, Kubernetes will manage that. You don't have to worry about it. So much of advantage you have in the Kubernetes. So they will manage it. Make sense, guys?
Yes.
So guys,
Yes, Rajesh. Yeah.
with that, we need to understand the Kubernetes architecture. Look at it here, this image. In this architecture, this image, this slide, you have one image which has a one cluster. The definition of cluster, you know that very well. Cluster means multiple nodes being formed together for one particular work. So here you see how many nodes you have in this cluster. We call it Kubernetes cluster. So in this cluster, you have a 7 node. Okay, you see here, node 1, 2, 3, 4, 5, 6, and here master is also on a node. It can be physical machine, it can be virtual machine. Now, if you see that here you have multiple master, because see, master is very important, coach is very important, manager is very important, because you know that if manager is not there, master is not there, a coach is not there, all the players, all the service will become controlless. That means who will control the flow of the communications? The game will be spoiled. No coordination will be there. So your end results will not get it, right? So master is needed, but if there is one master and if this one master get failed due to some reason, hardware or software, then your entire cluster will be in a chaos state, right? Not good state. So here, to avoid that, you have a multiple master. You see that the icon behind the icon, you see that the boxes? That means multiple master is possible. So here in a Kubernetes cluster, you have a multiple node and you have a one master, but at a time, but multiple master for the backup. Now the question is, master controls the node. Look at this here. Master controls the node, but who controls the master? See, there's one package coming from. Look at the image. One deployment package. So this deployment package, who writes it? Who writes it, this deployment package? So guys, this is your job to write a deployment package. I told you, remember? Manage Kubernetes will help you to manage the desire. That means whatever the desire you have, you send it to Kubernetes, and Kubernetes will help you to get it completed, that one. Are you getting opens? Are you getting opens? So are you getting my points, guys?
Rajesh, can you tell me what is this rectangle box? Because you given an arrow mark, right? Can you reiterate one more time?
That's your desire, what you want inside, what you want to see inside a cluster. Desire means that some deployment packages which we created. That I'll come back to you. What is there, it's not important. The flow is important. You are creating some package. That package creation, I will teach you, but the flow is important right now. You are creating something, what you want. Send it to the master. A master will get that work done with the help of node. Master and node is being called as a Kubernetes cluster. Make sense?
Rajesh, each node is a VM, right? And master also one.
Yeah. Each node and master, it can be VM or physical machine.
Okay.
So guys, who's in charge? Master. Who's doing the really work? Node. Now look at this, guys. Here I see node has one thing called pod. And one thing called pod. So the pod, what is a pod? I don't know. Okay. But inside a pod icon, you see there is one icon called container. Okay. See that carefully. So deployment package is been sent to master. Master get the work done from the node. Node has a pod. Pod has a container. What is a pod? We don't know right now. But container, what is a container? We know very well. What is container? We know very well. So guys, with that, let's understand master. Master, the one we are going to discuss about it in detail now. So in the Kubernetes cluster, we have a master and node. We are discussing about the master. Masters, we also call it Kubernetes control plane. Sometimes you also hear control plane, control plane, control plane. Okay? Okay? So Kubernetes control plane. So guys, master manages multiple nodes. You see that here, master has to be Linux only. Linux 64-bit. Node has to be in Linux only 64-bit. But the question is, in the today's in this year onwards, we have got the Windows support also. That means master has to be Linux, but node can be Linux as well as Windows also. But when it comes to the Windows, it's a 2019 plus only. Okay, so now with the little bit of change in architecture, node can be Windows also, whereas master has to be Linux only. Okay, so with that, what is their master? So guys, master has a 4 component. Which are those components? We'll come back. Master can be multi-master, means multi-HA, because I told you if one master controls everything, so if master is not working, second master should be taking that responsibility. So it should be multi-master for HA purpose. Okay. You see here, master manages the node. Node has a pod, and what is a pod we don't know right now. But interesting thing is, pod has a container. And if I look at the top left image, pod has 2 containers here. Containers, the one which we know. So here you see in the Kubernetes world, containers is inside a pod, and pod you have in the node, and node is been managed by master. What is a pod? Still we need to discuss that. But container, we know that. Correct? So this is the master, and master has a 4 component. Now let's understand which are those components. So guys, master's first component is API server. Master first component is API server. Now guys, there is a 2 word. Can you break it down? API server, that means there are 2 things, API and server. That means this is a server. For what? API. Which API? So actually, let me tell you guys in a simple way. Whatever the feature you have in the Kubernetes, whatever it is, whatever the feature you have in the Kubernetes, every feature you have registered with API server. Yes, all the feature. Okay, all this feature is registered with API server. But how it has been registered? So basically, all the feature has been registered in form of API. Yes, API. So you can consider API server is your registry. Registry definition, you understand that registry, right? So you can also call this API server is as registry for API. Means this place you can find all the feature of Kubernetes, all the feature through multiple each and every API. So guys, in official keywords, what we call it, API server is nothing but a front end. Yes, it's a front end to control plane. In a short, if you want to send some communication to Kubernetes cluster, you send it to API server. Yes, you want to send it any communication to the Kubernetes cluster, you have to interact with API server. It is a front end. It is like you have office, right? And in the office front gate, there will be one reception. So if anyone wants to come inside and communicate with any one of us who's working inside office, they need to talk to the reception. It's like this. It's a front end to the control plane. And how can you access this API server? Through REST API, you can access HTTP. Okay. Now, which form of request you want to send it to this API server? So guys, the request is receiving this API server in a JSON format. By the way, all the API receive the request in the JSON. REST API you receive in the JSON format. So guys, this is the API server, which is the first component of the control plane master. Guys, are you understanding this?
Yes.
Okay. So now the second thing is, what is the second component? Second component is cluster store. Cluster stored. Now the question is, what is a cluster store? So guys, see, if you get any request, you have to store it somewhere, right? Without storage, how can you remember? You have to store it. How can you know that which has been asked, what has been asked by the human being? So there is a second component which you see that, look at the arrow also. Second component what you can see is cluster store. We call it etcd also. So what is a cluster store? So guys, cluster store is nothing but persistent storage. Yes, anything which you are doing inside a cluster of Kubernetes, everything is getting stored in the cluster store. What exactly everything? So it stores the cluster state and configurations. Now this storage is based on the which technology? So guys, it uses the etcd. etcd is one of the distributed, consistent, watchable, key and value based storage tool. Recently it's become very popular. It's open source also. Okay, you can check it out on their GitHub website. Okay, so this cluster store is empowered by etcd, and actually this is a source of truth for the cluster. When I say source of truth, means whatever it has in this etcd, that's there you can see inside a cluster. If you have not stored here, that means that is not existed in the cluster. Simple statement, not complicated. So basically you have to have a backup plan for it also. Let's visualize this component with some real-time character. Probably that will be more beneficial for you. So this is the image.
If you liked our Kubernetes session so far, please enroll for our channel membership $399 plan to get access of all the parts.
So this is the image. Now if you say this is a control plane, this is the control plane of your body. Similar to that, master is a control plane of your entire cluster. Now if I look at the API server which receive all the requests, so your ear is a API server. It receives everything. Whatever someone requests, you get it, you receive. Now immediately is stored in the memory. That is called KB store or etcd. So here this is API server, something like that. Storage is happening here. Then you try to, so you got something, see here, you got some version of some statement. You stored it here. Now you validate. How do you validate? Whether statement is true or false, or things are correct or wrong or right. How you validate?
We'll think.
Eyes.
It's what?
You will see that. You will see that reality from your eyes. Now, how many eyes we have? 2. Okay. So, 2. So now these 2 eyes observe the fact check the fact, and again update to etc. See here how it works. Receive, store, monitor, update, etc. Now with that context, look at and learn the third component. So here we have third component, which we call is as controller manager. Understand that, guys. I said controller manager. If I see, manager means manages something. Now controller means control something. Control something. So that means controller manager is a component which has multiple controller, which manages the multiple controller, such as node controller, endpoint controller, namespace controller. So what is basically it's control? It's control for whether it's mismatch or not. And you keep watching for the changes in the cluster. Okay, so same way, the one which I was talking about, I look at this everything and keep updating your memory, saying that okay, this was the desire, but this is the status. You see, desire also you got it, real status you also got it. So eyes, how many eyes we have? 2 eyes. In Kubernetes, how many controllers we have? So many controllers we have. Node controller will check the node, whether it's a node up and running or not. Endpoint controller will check the endpoint, whether it's accessible or not. And namespaces and many more things. So controller again talk to which one? Controller again talk to API server, because it's a front end. No one can talk to the cluster store except API server. So controller manager talk to the API server. Through API server, you update the cluster store with the current state of the cluster information. Now, what happens when API server detects desire? There is a mismatch in the desire and the information which was sent by controller. Then what happens? You know, that is where API server invoke the fourth component. And that fourth component is a scheduler. By the way, guys, controller runs in the loop. Controllers never stop. If the controller stops, Kubernetes will stop working. So it never stops. So here you see kube scheduler. See here what happened. Kube scheduler watches API server for new pod. And kube scheduler only, please read this very important statement. Kube scheduler only watches the API server for the new pod and it assigns work to the nodes. Who assigns the work to the node? Scheduler. At a high level, when I say who assigns the work to the node, master, we call it control plane. But if I go and see that architecture, scheduler assigns the work to the node. And guys, scheduler has anti-affinity and affinity. Affinity and anti-affinity means scheduler say I will assign the work to one particular node only. That's called affinity. You can set it up. And scheduler, when they assign the work to any random, healthy, available resources node, then that's called anti-affinity. So you can have affinity, anti-affinity, constraint, and resource constraints, everything you can have it. Based on that, scheduler can assign work to the node. So if I see that here, who can assign the work to you? Your mouse, correct? This is assigning the work, not doing, remember, mouth. So mouth will tell you, okay, you do this, you do that, this is not done, this is not done, this is completed, this, that, whatever it is. So mouth will assign. So same way, scheduler will work like a scheduling, schedule the work, never do the work. So guys, these are the 4 components we have in the master Aka control plane, and this we call it master. So did you understand this? What is a master now? Did you understand this? What is a master now?
Yes.
Guys, so it's very important. Now guys, can you please read this, each and everyone? It's very important for all of us. This is a short description about what we discussed so far. So guys, API server is central, simple, restful, and update a etcd. Cluster stored, which store the persistent state in form of keys and value, powered by etcd, and you can watch it. It's distributed and many more. Schedule watches the API server and schedule the pod. See, pod, I don't know what is that pod. But still, I think I know few things information. Like a pod is inside a node. And inside a pod, you have a container. Now what is a pod? We don't know, but who is scheduling the pod? Scheduling, remember. Scheduling the pod to the node is scheduler. So remember that. Scheduling of the work is done by scheduler. But when I say work, that means pod. Think about it. Resources and resource content. And here controller manager, which runs in the loop, manage the help you to the desired lifecycle, watches and update the API server, and manage the replica. Many things. So guys, this is a little elaborated architecture. Please spend some time very carefully. See here, look at this. You have a master, core component. Look at the arrow, which talk to which one, you understand this. Scheduler talk to the node. Node has a pod. Pod has a container. But the question is, who's requesting the API server? The question is, who's requesting? So guys, we request you. We are the human being. We have a laptop. A laptop should be there. Which utility? Laptop should be having which utility? Laptop should be having kubectl. Please remember this. Laptop should be having kubectl. You can look at the image itself. That means, in a simple way, guys, if you really want to talk to your cluster, you can talk to your cluster through kubectl. Kubectl, which communicate with API server, and what you send in API server? Desire, what you want. How? Which format? JSON format. That's your package, deployment package. You can write in YAML also, you can write in JSON also, but API server always accept in the JSON format. So this is a little bit elaborated format of architecture. Are you comfortable? Can we move on?
So Rajesh, the kubectl is part of Kubernetes architecture, right?
Sir, kubectl is a part of your laptop. Using that, you send the instruction to API server. That's what I'm telling you. Look at the image. It's a laptop image. Where is your laptop? You will be having laptop. That's your laptop currently, which you are logged in and attached to the session. You will have a kubectl here. Through kubectl, you will talk to API server, which is a cluster. From API server, you know the rest of the things. Got it?
Okay.
Okay, guys. So now you have understood well. So now we should know little bit of worker also. Okay, we should know little bit of worker also. So guys, let's know about the worker. So worker aka minions. Aka Kubernetes worker. So have you watched this movie called Minion? Anyone? Anyone who have watched this movie?
Despicable Me.
Yeah. So I think you have not. If you have not watched, this is the right time to watch actually. and it's very interesting animated movie. Very wonderful movie actually. See this. This is very good for kids. There were two versions, I guess. Yeah, Minion and Minion 2. See. So minions are like a kind of species. Okay. So if I tell you the story, it's a very interesting story. Minions get up in the morning, and all the minions become sad, like this. See here, this one. You can see my cursor. They become sad. All the minions. Why minion become sad? Minion become sad because of one reason, that they do not have any master. So if I tell you in the simple word, minion is a kind of species of slave. And slave is sad. Why? Because they do not have a master. So the definition of their life is not exist. Meaning of life is not exist without a master. They are made for masters, to serve masters. Okay. So minion gets up in the morning, they become sad, and the minions started looking for their masters. And in the movies actually, they travel the whole world. There's a very nice story, you must watch actually, you might find in the Prime also. So they travel the whole world in order to find out the master. And the moment they found the master, all the minions get so excited, so happy, and they started bugging the master. Master, give me the work. I am healthy. I am alive. I am having this much of I'm having this much of energy and stuff like that. So keep bugging the masters. But master will give the work only if they have the work. So the moment the master will give the work to the minion, one of the minion will do immediately. No further question asked. They will do immediately the work and immediately send back to the report back to the master and said, Master, I did my work. Give me more work. I am again healthy. I am again available for you. So this is a kind of story. Again, in some climax is also there in the movie. You must watch and then you'll understand. But overall, what I'm trying to say here, minion, aka slave, aka worker, aka nodes, whatever you want to call it, is the behavior of minions and nodes also. So guys, nodes has a 3 component. Nodes have 3 components. Which are those? So first one is a kubelet. Remember, the one which you have in the workstation. I said workstation, not worker. There's a difference between the workstation, which is your laptop, and when it's a worker, it's a node. Please mind it. So kubelet is acting like a minion only. Kubelet is the one which you find in each node is acting like a minion only. So the moment it gets up, when I say gets up means the moment you run this utility, they will look for the master which they will read some configuration file, API server basically, request master to become a slave, and after that get some work, complete the work, report back to the master, and keep bugging and keep updating. Basically bugging means keep updating the master with the information what they have. So that's what here we are trying to say. Kubelet is the main Kubernetes agent which is keep on running in each node. This kubelet only helps register a node with the cluster. Yes. See, understand this. Master never decide who's your worker. Always minion decide, the slave decide, the worker decide who's your master. And it keep watches API server, keep bugging API server. schedule some task to the kubelet. So kubelet instantiate a pod. Fourth line, please mind it. Who instantiate? Who create a pod? Kubelet. Who schedule the pod? Scheduler. Who asked to schedule the pod? API server. Based on mismatch of etcd data of the desired versus actual. See that relationship. And kubelet is running on a 10255. So this is the agent. Now guys, this is something which you know now well. This is the Kubernetes engine, sorry, container engine, Docker. Here in this, it can be Rocket also. It can be Rocket also if you don't like. So this is the main Kubernetes, container engine, which basically create a thing. Because remember here, node has a pod. Pod has a container. So who will create a pod? Kubelet. Who will create a container inside the pod? Container engine. Whose container engine? It can be Docker, it can be Rocket, it can be any other CryoD and practice is that and all. Okay. So understand this. So you have got the two components so far. The third component, remember guys, I said one statement very clearly. She just stated there. How these containers will be accessible to the load balancer, because without a proxy, how these containers will be able to access. So here understand that guys, container don't need to connect with the load balancer. Why? Because container is inside a pod. So here in Kubernetes, people connect to the pod, not the container. Yes. So what has happened? Kubernetes has written one wrapper around the container. This is called pod. And pod is directly accessible to the load balancer. How? I'll discuss in the service section. But you should please read this statement. The networking requirement of the Kubernetes. Please understand that. How can that be possible, whereas all pods can communicate with each other? Understand that. All pods. Here I am saying, if the pods across the node, here all the pods. See here, this container cannot talk to this container, but the pod should be able to talk to the pod other node also. That is what I am saying here. So here, all pods can communicate with each other on all the nodes. All nodes can communicate with all the pods, and no network address translation should happen. No NAT. So how can that be possible without a NAT? That is being done because of kubeproxy. Guys, please read this document, the slides. Kubeproxy. So guys, what is a kubeproxy? So kubeproxy is basically Kubernetes networking services. And kubeproxy assign IP address. Please hear me out clearly. Kubeproxy assign IP address to what? Pod. Yes. So here in the world of Kubernetes, container do not get a single network here. Pod gets a single network. So here, because who's assigning that one? Kubeproxy. So kubeproxy assign the pod IP addresses. So because I told you inside a pod you have two containers. So all containers in a pod share a single IP. Yes. So if you are running 5 containers, 10 containers, 15 containers, share a single IP. Why? How come? Because of pod. And because of pod, only load balancer works. Load balancers across all pods in a service happen because of kubeproxy, guys. So this is doing all the mantra, but which is a part of Kubernetes. This is a part of Kubernetes. So guys, did you understand this? This is the third component of the worker, aka minion, aka node. This is called kubeproxy. So now, guys, finally what you have in the worker, kubelet, which is the main Kubernetes agent, container engine, which can be Docker and Rocket, kubeproxy, which is a Kubernetes networking service. So guys, look at it, this image, very important. Everyone.
So, Rajesh, again, here it is not individual container load balancing, right? This is only pod load balancing in that case, right?
Yes, that's correct. Yes, that's
What is the job of the kubelet, Rajesh, here?
So kubelet is the agent, minion, remember? Minion, agent, minion. So kubelet is the tool which runs in the each node, and if you run the kubelet, they will register with the master, and then after that they'll keep sending the data to the master and about availability, and then scheduler assign the node through kubelet only. Okay. So guys, this is the nodes. Please read this one also, it's very important. So guys, kubelet is a monitors the API server for changes, responsible for pod lifecycle, means it manages the pods, like a Docker manages the container, right? Same way kubelet manages the pod. Kubelet report back to the API server and pod state, some liveliness probe and stuff like that. Kubeproxy is the network proxy for IP tables, implement services, routing traffic to the pod, helps you to load balance. Container, you know that very well. So that is done. So guys, we have few more add-ons component in the cluster. We call it DNS services, ingress services, dashboard. So we'll talk about once the needs arise, not complicate everything at once. With that, guys, we discuss about master and worker. What we did not discuss about the human being, correct? Remember, human being has a laptop has a kubectl, and then he writes the package, declare the package. So now it's all about the game of master is there, worker is there, workstation is set up, but you have to deploy the package, right? Package is important, because I told you, if you have a package, you send it to the Kubernetes master, rest of the things forget about it. So the question is, how do we declare? So guys, earlier, look at this. Nowadays, we are in the world of declarative language. Okay, a declarative language means, see, earlier we used to have a compiled language like a Java or C++. Then we got interpreted language like what do you say? Python, Perl, PHP. Then we got a declarative language like XML, JSON, YAML, and all. So declarative model, we don't need to write too much of programs of what we want. Just you have to, whatever the simple desire what you have in a simple language, we just need to put it, declare. So it's like this, declare your desire in what file. So you can put it in YAML file or JSON file. Declare your desire in YAML or JSON, send it to API server through kubectl, and then rest of the things happen. What? So here you see here, you declare I want 3 pod. Yes, you want. In the Kubernetes, we always work with the pod. But what is a pod? Still we have not discussed so far. What is a pod? We have not discussed so far. But we want the pod, and pod. See, one thing we know, kubelet. See that. One thing we know, we deploy a pod. Pod has a container. A pod can be done in the node worker. Pod is created by kubelet. Okay. So these are the things we know. So we deploy, we declare in YAML or JSON, we declare our desire. What is your desire? 3 pods of what? Nginx. Send it to API server and boom. You got it. 3 pod, you got it. If you have 3 nodes. Now who's doing the work placement? You know that who's doing, scheduler is doing the work placement. Take 1, 1, 1. Now suddenly one node got disappeared because of it can be any reason. So here, see what was the desire? 3. What is actual? 2. Mismatch. So who will update that API server? There's a mismatch. Controller manager, you know that. Controller manager immediately respond that I am getting only the 2 pod in entire cluster of this kind. So API server will ask scheduler, boss, can you please create one more pod? Scheduler create one more pod. This is the thing. You don't get up in the midnight stating that production is down. Desire and actual is matched. Everyone is happy. So now the question is, now back to the major question is, what do you want to desire? Because your work overall is to understand what to desire, what do you want. Because Kubernetes stated, I will give you whatever you will ask for it. But you ask something, you deploy the package. So guys, our job is to learn what is desired, what to be desired, what to desire. What do you want? What do you want? You want pod, you want controllers, you want service, you want storage, you want network, you want this, you want security, you want load balance. What you want? Just tell me. Whatever you want, just tell me in form of YAML and JSON, send it to the kubectl to API server, and rest of the things you know that, and rest of the things is my job. So in the Kubernetes, you see that I told you health, wealth, everything. So in the Kubernetes, just imagine, just visualize in your mind. Just one person has to write what they want, send it to the Kubernetes, and Kubernetes can manage such a huge infrastructure on behalf of you with a minimal capacity. So organization will get lots of wealth. They don't need too many engineers to manage the production. And same time, you will not be called in the midnight, overnight, late night, weekends, this, that, and you get a benefit of health, right? So ultimately what you want to run, what you want to learn, what to desire. And that is what we are going to focus on now. So guys, so far, are you clear with the architecture?
Thanks for watching. If you liked our Kubernetes session so far, please enroll for our channel membership $399 plan to get access of all the parts. Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devops.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.